All right, the next concept we're going to talk about is dominance. And we say that one function dominates another function if, in the long run, one function is greater than another. All right, just in the long run. So as x approaches positive infinity, right? So here you can see the functions y equals x and y equals x squared. Now there are values of function where x squared is less than the values of x, right? If x is between 0 and 1, we get values of x squared that are less. But in the long run, as x gets bigger and bigger, x squared is always going to be bigger than x. All right, so we say that x squared dominates x. All right, the same thing would happen if we had the square root of x, which isn't drawn here, but I could draw the square root of x. Looks something like that. It's going to pass through 1, 1, because the square root of 1 is 1. So this would be y equals the square root of x, and you could see that there is a portion of the graph where square root of x is greater than x, but in the long run, x is always bigger than the square root of x. So we say that the function x dominates the square root of x. All right, so that's the idea of dominance. It's just what's happening in the long run is one function always going to be greater than the other function in the long run. Now, some of those long runs might be longer than might be long, so we need to look at the long run behavior of these functions. All right, so let's take a look at example 5. We have two functions, f of x equals x cubed, and then we have g of x is equal to 100x squared. All right, so now in the short run, 100x squared is probably going to be bigger because we're taking x squared and then we're multiplying by 100. But eventually, x cubed is going to take over. So let's look at where does it start taking over. So let's look at for what values of x is f of x greater than g of x. So what I'm going to do is just substitute f of x is x cubed. I want to look at this inequality, x cubed is greater than 100x squared. Okay, so I want to know what values of x is that true for. All right, now we're going to do some algebraic manipulations with an inequality, and you have to be careful, be very, very careful. Do not divide both sides by x or x squared. All right, the reason for that is, if you remember, if we multiply or divide by a negative, we had to flip the inequality around, right? And we do not know. X could be positive or it could be negative. So if we do that, then we won't know which way the inequality goes. What we're going to do instead is subtract 100x from both sides. So I'm going to get x cubed minus 100x squared is greater than 0. So now I'm just looking for what values of x make this x cubed minus 100x positive. All right, now I see a common factor of x squared. Let's go ahead and factor that out. So let me get x minus 100 is greater than 0. All right, so we're looking for the where this expression x squared times x minus 100 is greater than 0. Now x squared is always positive. So the thing that's going to determine whether this is positive or negative is just this factor of x minus 100. So really now we just need to look at where is x minus 100 greater than 0, because when x minus 100 is greater than 0, then the whole thing is going to be positive, right? This whole x squared times x minus 100 is going to be positive, right? Because the x squared is already positive. All right, now we can add 100 to both sides. So x squared is greater than 100. So that is where, for values, those are the x values for which f of x is greater than g of x, g of x, for x greater than 100. All right. So when x is greater than 100, then it takes over. And that sort of makes sense because 100 cubed would be 100 times 100 times 100, right? And 100x squared would be 100 times 100 times 100. And then from there on, if x gets bigger, then this is essentially x times x squared, and this is always just going to stay 100 times x squared. So it makes sense. But what this tells us, though, is that f of x dominates g of x. Dominates g of x, right? Because as long as x is greater than 100, so in the long run, f of x is greater than g of x. So we can say because f of x is greater than g of x in the long run. Or you could say as x gets larger and larger, or for large values of x. But for large values of x, right, in the long run, f of x is always greater than g of x. All right, so f of x dominates g of x. All right, I'll meet you in the next video for the next example.